Hey guys, this is our first little lesson on series and sigma notation. So the first slide on the notes is just like a kind of a review of some of the things that we learned in the last lesson. I'm going to do these. Basically, this would probably be the warm up if we were in class, like live in class. I'm going to go ahead and run through these real quick and do a couple of the things about series and then partial sums, and then we'll talk about sigma notation in the next video. But basically, we have these, I guess, three questions here. So here they give you a sequence, 7, 10, 3, 16, 19, and they say find the 10th term. And maybe you can see that to get from one term to the next here, you're just adding 3 each time. So A1 is 7, A2 is 10, A3 is 13, A4 is 16, A5 is 19. So A6 would be 19 plus 3 is 22. A7 would be 25. A8 would be 28. A9 would be 31. A9. And A10 would be 31 plus 3 is 34. So that's pretty straightforward, I think. Just a 10th term. Part B is significantly less straightforward. It's like write an expression for the nth term, kind of like this one that says the number sequence has an nth term 6n plus 3. We can do this one first. Write down the first 4 terms. This you just plug in the index for each term. So I'd say A1. That means n is 1. So 6 times 1 plus 3 is 9. A2. Plug in 2 for n. 6 times 2 plus 3 is 12 plus 3 is 15. A3. 6 times 3 is 18 plus 3 is 21. Looks like we're going up by 6 each time. A4 is 6 times 4 is 24 plus 3 is 27. So yeah, it goes up by 6 each time. We might use this concept that this goes up by 6 each time to answer this question. The reason this one goes up by 6 every time is because of this term 6n in here. Like when n is 1, this is 6, and when n is 2, this is 12, and when n is 3, this is 18, and so on and so forth. Basically, every time n goes up by 1, or increments is the word we use for that, the value of this thing increases by 6. So for part B here, write an expression in terms of n for the nth term. If this thing goes up by 3 each time, that's going to imply that there's a term in here, like a term that is 3n. Because now when n is 1, this is 3, and when n is 2, it's 6. And when it's like this keeps, as n goes up by 1, this term goes up by 3, which is what's happening here. And the trick is just, given 3n is in this, the first term here is 7. So A1 is 7. And so I say 7 is 3 times 1 plus something. That's how I'm going to write this term. So a sub n is 3 times n. In this case, a sub 1 is 7. Is 3 times 1 plus what number? Well, 3 times 4 is 7. So I put a 4 here. And I can see, and I can kind of try it. I'm like, does that work? It's like a good guess. So when a is 2, 3 times 2 is 6 plus 4 is 10. That worked. When a is 3, 3 times 3 plus 4 is 9 plus 4 is 13. That works. This looks like it's going to work. And I kind of can tell it is because the first term works. And then every term after that, n just goes up. This term goes up by 3, and that's what's happening in the sequence as well. Just for fun, for funsies. A10, I put a 10 in here for n. 3 times 10 is 30 plus 4 is 34. So that works. So that's how I would do a problem like that. There are going to be more of these when we do the lesson on arithmetic and geometric sequences next, but that one just kind of popped up in there. So we know what a sequence is. It's just like a list of, like an ordered list of terms, where every term has an index, 1, 2, 3, 4, whatever associated with it. A series, though, a series is a sum of the terms of a sequence. That's probably not the exact technical definition, but it's good enough for our purposes right now. This word is important. Remember, sum means adding. It's about putting terms together. And the series is about sum. Sequences are just lists of numbers with commas in between them. A series is going to be a sum, so it's going to be a bunch of terms with pluses in between. And this actually turned out, I just realized, was in your homework for last time. I think on the next slide, these S sub whatevers, these are called partial sums. And they're like always of the form S sub n, where the n is, this means like add up the first n terms. So here S1 means add up the first one term of this sequence. The sequence looks like it's even numbers where the signs start negative and then alternate positive, negative, negative, positive, so on and so forth. So the sum of the first term is just -2. There's only one term. S4 is the sum of the first four terms, -2 plus 4 plus -6 plus 8. And the fact that there's pluses in between these tell me that it's a series and not a sequence. So maybe -2 plus 4 is 2, and -6 plus 8 is also 2. So when I add these all together, I get 4. S5 is -2 plus 4 plus -6 plus 8 plus -10, which is 2 plus 2 is 4, minus 10 is -6. And you might have noticed as we were doing this that like the first four terms of this is S4. So S4, you could have done this by just doing S4 plus -10, which is also -6. Since we already knew what the sum of the first four terms was, 4, we just have to add the fifth term to get S5. Now I could say, well, S6 would be you just add the sixth term to this. 1, 2, 3, 4, 5, 6. The sixth term, S6, is -6 plus 12, which is 6. So you don't actually have to add all 6 terms every time if you've already done it back here. So that's the basics, the very, very basics of what sequences, of what sums are. And we will do sigma notation in the next video.